Next couple of questions, we have some solids of revolution. Let's look at exercise 2. The rectangle shown can be rotated around the y-axis or the x-axis to make two different solids of revolution. Which solid would have the greater volume? Well, first of all, I take a rectangle, I rotate it around an axis. What three-dimensional shape does that make? It's going to make a cylinder. So let's say I rotate it around the y-axis. Rotating around the y-axis, so it should be a cylinder, sort of like that. Boop. Okay, and then if I rotate it around the x-axis instead, the cylinder is going to look maybe like this. And then boop, there we go. Right, and so a common misconception that students sometimes have on this is that, well, the volumes are going to be identical to each other. You're taking the same rectangle, rotating around the axis, doesn't matter how you rotate it, you're going to get the same volume. Let's see if that is the case. This one is the y-axis, and this one is the x-axis. Let's do the one across the, or around the y-axis first here. Come on, eraser, function for me properly. All right, maybe I sketch a little picture for this. I'm taking this rectangle. I'm gonna rotate it around the y-axis here. And when I do, once again, I'm gonna get a tall, slightly skinnier cylinder, like so. And what I'm going to do, and what I generally like to do, is draw in the axis, which is the y-axis that's right here. So it like comes up here, right? So there's the y-axis. And not only that, if I put in the radius up here, oops, here's the radius and the radius down below, then there's the rectangle that I would have rotated. It's this rectangle right here, would have rotated in order to generate that solid. Okay, and then it only gave us one piece of information, and that's the corner, that corner coordinate, which is 4, 6, right here, 4, 6. So whenever I go to plot that point, of course, that means I'm going to go to the right 4, which means that this base length of that rectangle is 4, and then I go up 6, has a height of 6. The 4 that's down here in the bottom, whenever this thing wraps around the y-axis, that forms the radius length. So I have a radius of 4. Maybe zoom in here a little bit. Whoa, where'd you go? Where'd you go? 4. Okay, and then this will correspond to the height. Right? Is that enough information to find the volume? It should be, because the volume of a cylinder is pi r squared h. We just need a radius and we need a height, and that's it. Volume is equal to pi times my radius, which is 4 squared, times my height of 6. 4 squared is 16. Let's see, I got 16 times 6. It'll be 36, and 6 is 96. I got a total of 96 pi. And this is in the coordinate plane with no specific units, so I'll just call it units cubed. All right, there we have it across or around about the y-axis. Let's do the exact same thing over the x-axis. Maybe I even switch colors here. How about green? Green and purple, they look real good together. X-axis. Sketch my picture once again. Okay, this time when I'm rotating it around the x-axis, I'm going to have a wider cylinder. And it's not sitting on its circular face this time. So once again, I'm going to draw in the axis. I don't know, that looked like trash. Let me get rid of, no. Let me clean this up just a little bit there. Maybe make it a little bit smaller. Oh, that looks way better. All right, and then continue it. So there's the x-axis there that we spun it around. And just like I did before, I'm going to draw in the radius here and then a radius over here. I did that because there is the rectangle that we spun around the x-axis in order to generate that three-dimensional solid. So remember, this point was 4, 6. Still, that's a 6, that's a 4, which means that this time the radius is 6 and the height is 4. So now whenever I go to compute my volume, pi times my radius 6 squared times 4. Even though it uses the same numbers, it's using those numbers in different places. I'm squaring the 6 this time, so this time I got 36 times 4. Let's see, 424 and 12, 144. I think that we have a winner. 144 pi units cubed. All right, let's think about this for a second. Let's come back up to this original problem. Could we have anticipated that it was the one that went over the x-axis, which was going to have a greater volume? And what do you think? Like, think about what had happened. Like, the 4 and the 6, whenever we were spinning this around the y-axis, the 4 was the radius which got squared. And over here on the x-axis, it was the 6 that was the radius that got squared. And when we have a larger base, that contributed more to its overall volume, which made it have a greater volume than the other one.